Hello everyone, welcome to new class. Today's class is about resonance in parallel circuits. The parallel resonance circuit is generally called a tank circuit because of the fact that the circuit stores energy in the magnetic field of the coil and in the electric field of the capacitor. The stored energy is transferred back and forth between the capacitor and the coil and vice versa. The tank circuit is shown in this figure. The circuit is said to be in resonant condition when the susceptance is 0. Also at resonance, the reactive component of the line current is 0. The phasor diagram of the above circuit is shown in the figure. The current through the inductive circuit is IL and through the capacitive circuit is IC. That is shown in this figure. And the current IL has two components. One is active component IL cos phi L and the other is reactive component, that is IL sin phi L. The current IC leads the voltage by 90 degree, and at parallel resonance the net reactive current is 0. At parallel resonance the net reactive current is 0. That is IC minus IL sin phi L equal to 0. Under this condition, the circuit is purely resistive. That is, power factor of the parallel circuit is unity. And IC is equal to V by XC, IL is equal to V by ZL. And ZL is square root of R square plus XL square. And this is the variation of impedance and current with frequency. At a resonant frequency, the current is minimum and impedance is maximum in the case of parallel circuits. This is the impedance diagram for the resistor inductor combination. So from this, sin phi L is equal to XL divided by ZL. And we have ZL is equal to root of R square plus XL square or RL square plus XL square. So at resonance, IC is equal to IL sin phi L, and we have V by XC is equal to V by ZL into XL by ZL. On rearranging, we get XL into XC equal to ZL square. That is omega L divided by omega C equal to ZL square, or L by C equal to ZL square. Put as equation 1, and ZL square is R square plus XL square, or R square plus 2 pi FRL the whole square. From this, 2 pi FRL the whole square equal to L by C minus R square. That is 2 pi FRL equal to square root of L by C minus R square. That is resonant frequency FR equal to 1 by 2 pi L square root of L by C minus R square, or 1 by 2 pi square root of 1 by LC minus R square by L square. Next is variation of impedance with frequency. This is the resonance curve for a parallel resonant circuit. or for a tank circuit. The resistance of a parallel resonant circuit is resistance or impedance is maximum at resonant frequency. At frequencies below the resonant frequency, most of the current flows through the coil, and hence the parallel resonant circuit acts as a coil. That is, at frequencies below the resonant frequency, XL will be very low. So, most of the current flows through the coil because this part is very low than the capacitive reactance. So, in that case, the parallel resonant circuit acts as a coil, that is XL is very greater than XC in that case, and above the resonant frequency, the circuit acts as a capacitor. The sharpness of the resonance curve depends on the Q of the coil. A high Q coil will yield a much sharper response curve than a low Q coil. The condition of parallel resonance is also known as anti-resonance. A parallel resonant circuit is also called a rejector circuit. As it can be used to reject a particular frequency. Under resonance, the reactive component of current is 0 and the total current through the circuit is IR is equal to IL cos phi L, and IR is V by ZR equal to V by ZL into R by ZL, that is 1 by ZR is equal to R by ZL square, and from this equation 1 by ZR is equal to R by L by C, or ZR is equal to L by C divided by R, or ZR is equal to L by C into R, where the impedance ZR at parallel resonance is known as the dynamic impedance. And the current flowing between the capacitor and inductor is much higher than the current supplied by the source. Therefore, we have a resonant current step up in a parallel resonant circuit, just as we have a resonant voltage step up in a series resonant circuit. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel for more classes.